Hello engineers, welcome to another video on low-level design. In this video, we'll look at a very interesting pattern called the flyweight pattern, which uses memory very efficiently. I hope you're ready. Let's get started. So as always, we'll start with the intent. Use sharing to support large numbers of fine-grained objects efficiently, right? So this pattern mainly focuses on memory efficiency. How effectively can we use our memory, right? So in order to understand this pattern, let's understand the use of text editors. So let's say I'm typing on my keyboard the keys A, B, C, D, right? So when I'm typing A, B, C, D, you're able to see them render on the screen, right? But the next time when I type A again, so are you seeing a new version of A or are you seeing the same A? So what I mean is the object A available in memory only once, or is it getting created every time I type A? So to create A again and again every time I type A would be very memory inefficient. But we can reuse the same A again and again just to re-render it. That way we can create the A once and reuse it any number of times. So that is what this pattern enables us to do. So how does it work? Let's have a look. Let's say in my memory, I have an empty box. Okay, and first time when I type A, there is nothing in the memory, so A is added to the memory, and this is the display where we are rendering everything. So as I type along A, first we are checking in the memory. Is there anything in the memory? No. So we create A in memory and then we display A here. Okay. Second time when we type B, first we check in memory, there is no B, so B is added to memory and then it is displayed here. So next time when I want to type A again, we check in the memory. Is A already available in memory? Yes. So we don't need to recreate again in memory. We can just call the A again onto the display. So I can use this concept again and again so that my memory is used efficiently. So you can imagine in large text editors where there's large chunk of text, there are a bunch of characters being rendered again and again. We can efficiently use memory in these type of scenarios, right? So this is slightly different from the prototype pattern where we created copies of objects, right? So here the copies are created and those copies are used. But in this flyweight pattern, we are not creating copies. We are just reusing. So the main idea is to promote reuse here. So that is the whole idea behind this pattern, okay? So let's look at some other examples of this pattern. Let's say in games, right, we can see backgrounds being rendered, right? So if you've ever played games like Super Mario, there is a constant background appearing again and again, right? The trees, the bricks, the walls. So these are immovable objects. They don't change their behavior every time. So they just need to be re-rendered again and again and again without changing any of its behavior. So in these type of situations, we don't need to recreate them again and again, but we can just re-render them again and again, and we can use the same objects by using concept of reuse and memory sharing, right? So we are putting them in memory once and reusing them again and again, right? Same can also be seen in DOM rendering. If you have ever developed web applications, you know the concept of CSS, right? Where we are applying styles to components. So we can define the style once and the styles are saved in memory, and the same styles are getting applied to different objects again and again. So the styles are not created every time separately for a new component, and styles are shared among components, right? So here also we can see the usage of the flyweight pattern. So in order to understand how the flyweight pattern works, we need to understand a couple of things. Intrinsic and extrinsic state. So if these are sounding a little fancy, you can think of them as static and dynamic properties. Okay, so let's try to understand these concepts. So going back to our previous example where we are storing characters in memory, right? So let's say I'm storing A. So A can have multiple things as static. For example, the font size, the font, and the symbol itself, the symbol denoting A. So these are some of the things that can be static to it, right? These are what define that particular object, right? So these are static. So what are dynamic? So dynamic ones are the XY positions. Where to render this object? right? At which row and which column or which screen position we need to render it, at which X location and Y location. So this is dynamic and changing for every re-render, right? But these are static ones. So these type of properties are called intrinsic properties, and the changing ones are called dynamic or extrinsic properties, right? So if you are visualizing the Super Mario game, the tree that is getting rendered in the background, the tree has some properties, right? The number of leaves or the length of the bark and the height of the tree and so on. These are static to it. These are not changing, but the re-rendering position is changing, right? So those are the intrinsic and extrinsic properties. Now let's see how this pattern is implemented using the UML diagrams. So let's go to UML diagrams now. So this is the class diagram of the flyweight pattern. Okay, let's try to understand this. So there is a flyweight factory which is keeping the flyweights. So what are flyweights? So these characters which are there, right? A, B, C, D and so on. Whatever the little objects that we are creating, these are our flyweights. So they are nothing but lightweight objects. Okay, so this is what we are trying to reuse, right? So what are we trying to reuse? We are trying to reuse the flyweights. So there is a factory called FlyweightFactory which is storing these flyweights in some kind of a map. Okay, and the responsibility of the factory is to create and reuse these objects. So it exposes a method called getFlyweight, right? And in this method we are checking if flyweight exists already, return existing flyweight, otherwise create the flyweight, add it to the map and then return the flyweight, right? So this is a simple exercise of checking before creation. Okay, so first it is checking whether this particular flyweight is existing in the memory or not. If it is existing, directly return it, no need to create a new one. Otherwise create it, add it to the list so that next time we can reuse it and then return the new thing. Okay, so what are these flyweights? They can be anything. So there's a common flyweight interface. There can be concrete flyweights like this. Okay, and I spoke about intrinsic and extrinsic state, right? So the intrinsic state can have all these properties that we talked about before. For example, the font size, the font, the color and so on, right? So that can be intrinsic state of that object. Okay, and when we want to actually render it, we can pass in the XY values as extrinsic values. So these are the dynamic values that we are taking in as parameters, and then we can use these values to actually render something. Okay, so there is a simple flyweight interface which is implemented by a concrete flyweight. Okay, and then there is this optional piece called unshared flyweights. Okay, so not everything need to be shared. There can be situations where some of them need not be shared. So those can be shared separately in a different class called unshared flyweights, and they can be rendered as required. Okay, so this is something we can manage inside the getFlyweight method, whether to share it or not share it. Okay, so this is the entire structure of the pattern, the flyweight pattern, which is mainly used for saving memory. Now let's look at the sequence diagram. So in this pattern, the client will talk to the flyweight factory and create a flyweight factory instance. Okay, and it asks to get flyweight for every type of object. Okay, now the flyweight factory will decide whether to create a new instance if the flyweight doesn't exist, or return an existing instance. So from the client's point of view, they are getting a flyweight instance every time, but internally we are efficiently using the memory and reusing the shared objects. So once the client has that instance, client can call upon the operation, let's say display or render, and then the respective flyweight will render the corresponding object in a corresponding position, right? So that's the whole sequence of operation of the flyweight pattern. Okay, so let's take an example of the text editor. So this is a class diagram for the text editor. We have characters. These are our flyweights, the A, B, C, D that we were talking about before, and these are the intrinsic states, the symbol, the font and the size. So A of font, Arial of size 12, let's say. So these are the static properties, and then the operation is to display a character onto the screen, and to display we need some dynamic values, the X position and the Y position, right? So these are the extrinsic values. So this together forms a flyweight, right? And who is responsible for managing the creation of these flyweights? The Flyweight Factory. So this is the character factory which holds the characters. Okay. So what does it do? When it wants to get a character, it will check in the characters map whether the character already exists or not. If it exists, then it will return the object. Otherwise, it will create and return a new object. Okay. And because we are using a map, we need some kind of a key, because it is a key value storage, right? So we use an internal method for creating that key using the intrinsic properties. So for example, I want to save A of font size 12 of font Arial. This is a unique combination of a character. So this will form a key and that is stored in the map. Okay. And if I want to create a with a different font, let's say Times New Roman, so that becomes another object in the characters map and that will have its own key, right? So next time when somebody is asking to give a character A in Times New Roman, we will check in the map and using that key, and because it is available, we will just reuse it. Okay. So this is how the Flyweight pattern works. So inside the text editor, which is acting like our client, we can store two things. First, we have the factory using which we will call upon the get character method, right? And then we have the render, which will render all characters within the text editor, right? So for every time a user types a key, it gets added to the characters list inside the text editor. So here inside the text editor, it is storing both intrinsic and extrinsic values, because text editor needs to know where to render each character, right? So that is getting calculated and stored here, so that every time we don't need to recalculate them, right? So there's a character factory which is composed inside the text editor, which will take care of creation of the flyweights. And then the text editor itself is holding some of the characters so that it can render them on the fly with both intrinsic and extrinsic values, right? So this is the whole implementation of the Flyweight pattern. So using this pattern, we are saving a lot of memory. So let's see all this in code now. So I'm in VS Code now and we have a new file called flyweight.cpp, right? So let's go through this. First, we have the character class, which is having the intrinsic values, the character, the font, and the font size. And it is exposing a display method, which is taking in X and Y values as extrinsic state. So these are the parameters for extrinsic state. So it will just display the character at the given position, right? So this is our flyweight. And then we have the Flyweight Factory, which is the character factory, which is holding a map of keys as well as characters, the character objects, right? So it is holding the map and it is exposing a create key method internally so that we can create a unique combination of the key for that particular character. For example, a character with Arial font and size 10, right? So this forms a new key, and using that key, we can store the character object inside our characters map, right? So let's see. So in the character factory, we have the get character method, which will take in that unique combination of character. So here we are checking if the character already exists, then we can reuse it. If the character does not exist, which means the key is not found, we will create a new character and add it to the map and then return the new character, right? So that is what is happening here. Okay, so that is the Flyweight factory. And inside the text editor, we have two things, the characters and the factory. So inside this characters, we have both intrinsic state, which is a character object, and also the extrinsic state, which are the X and Y positions. So we are saving this so that we can render the characters on the display, right? So when somebody calls upon add character in the text editor, it will call upon the factory method of get character, which will take care of actually checking in the memory if the character is already existing or not. So either way, we get a character back and we are saving it to our list here, right? To our vector here, characters vector. So this will have both the intrinsic and the extrinsic states. Okay. And then when we are rendering, we will just loop through each character and render them. So a simple for loop here. Okay. So this is the text editor class. Now let's see the usage. So first we create the character factory and then we have the editor, which takes in a factory, right? So there's a composition relationship here. So first, let's say we are doing the string hello with font Arial and size 12, right? So for each character, we are calling the add character method in the editor. So first H is evaluated for font size Arial and size 12. Then E is evaluated for font size 12 and Arial, and so on. LLO, right? So every time we are changing the X position to 10 and we are keeping the Y position as 0. Okay. So all these are getting added to the text editor's characters vector. So when we call upon add character on the text editor, internally it will call upon the get character of the factory method, which will check whether the character already exists in memory or not. For example, H won't be available, H will be created, E won't be available, E will be created, L won't be available, L will be created, and the next time L is called, it is not created again, but it is reused from the existing object, right? And then O is called, O will be new character, so O is getting created. So for each of them, there will be one key in the characters map of the factory, and that key is used to evaluate the presence of it, right? After that, we can add some more characters L and O again, which will just reuse the existing objects, right? So we can see all this by printing the whole text. So let's run this and see. So as you can see here, this is how the sequence goes. First key is created as H Arial 12. So the character is H, the font is Arial, and the size is 12. So this is a unique key combination for that particular combination, right? And then we have E Arial 12, L Arial 12, and then second time when we call L, we are reusing the character, okay? And then we finally create the O. So next time when we were calling L and O again, we are just reusing the existing characters, right? After that, we can just render the text for different positions. You can see here character H is rendered at 0,0, E is rendered at 10,0, which is right next to H to the right side. And then we have L at 20,0, L at 30,0, O at 40,0. So we're just re-rendering them and not recreating them, right? And then we have L and O in the next line. So this way we can make use of the flyweight pattern to efficiently manage memory, right? So once again, these are not clones, these are just reuse of the existing objects, right? So that is the whole idea behind the flyweight pattern. Now let's see some trade-offs. So these are some of the trade-offs of the flyweight pattern. We are getting a lot of memory efficiency because we are trying to reuse the objects. And with that, we are also getting performance because there is no need to create new objects every time, and because we are using hash maps, it is one operation to check with the key in hash maps, so we get performance benefits there. And because we are using a Flyweight factory, the factory controls whether to create an object or reuse an object, so there is a central control that we are getting here, right? But let's look at some weaknesses. So we need to talk about additional state management, both intrinsic and extrinsic, so careful state management is required here. And then we need to keep in mind that only immutable objects should be shared, right? So if I create an A, it should be rendered as A every time I want to use it. It cannot change its behavior or change its font size or font on its own, right? So they should be immutable objects, right? And if there's a new combination of display required, it should be a new key, a new object, right? And that one also should be immutable. So that is something to keep in mind, okay? All right, so that's it for this video, guys. We have covered the intent, the example use cases. We talked about intrinsic and extrinsic. We talked about memory usage, resharing and everything. And we have seen some good examples. We have also seen the UML diagrams. We have seen the code walkthrough, and we have also seen some of the trade-offs. So if you have any questions in any of these, definitely put them in the comment below. This was the last pattern in the structural category of design patterns. If you have any questions, definitely ask me. Thank you so much for watching, guys. Don't forget to leave a like if you found this helpful. Do subscribe to the channel if you haven't done already. Share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.